They're invisible, monstrous. And yet, we know they exist. But how? How do scientists see black holes, objects that swallow light itself? Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity. Despite their invisibility, scientists have developed ingenious methods to detect and study them. By observing the effects of black holes on nearby stars and gas, and through gravitational waves, we can unveil these cosmic mysteries. Black holes don't emit light. They're not glowing in the dark of space. So if they're invisible, how can we possibly see one? The answer lies in their interaction with the surrounding environment. When a black hole pulls in matter, it forms an accretion disk that heats up and emits X-rays. These X-rays can be detected by telescopes. Additionally, black holes can be observed through the gravitational waves they produce when they merge with other massive objects. These ripples in space-time were first detected by LIGO in 2015. The event horizon, the boundary beyond which nothing can escape, and the singularity, the core of infinite density, are key features of black holes that scientists study to understand their nature. It all starts with Einstein. His theory of general relativity predicted that if enough mass gets squeezed into a small space, it would warp spacetime, so much that nothing, not even light, could escape. This idea was revolutionary. Einstein's equations suggested that these regions of intense gravity, which we now call black holes, could exist. But it wasn't until decades later that scientists began to find evidence supporting his prediction. Today we have observed black holes directly, confirming Einstein's groundbreaking theory. So instead of seeing black holes directly, we look for their effects. For instance, stars that orbit nothing. At the center of our Milky Way, stars whip around a dark spot at extreme speeds. That nothing is actually a supermassive black hole, called Sagittarius A*. The immense gravitational pull of black holes can also create ripples in spacetime, known as gravitational waves. Instruments like LIGO detect these waves, providing indirect evidence of black holes. Additionally, black holes can tear apart stars that come too close, a process called tidal disruption. These events release intense X-rays, which we can observe with space telescopes. The Event Horizon Telescope even captured the first image of a black hole's shadow, further confirming their existence. Some black holes suck in gas and dust, forming a bright hot accretion disk. The material spins and heats up, glowing in X-rays and radio waves. We can't see the black hole, but we can see the light around it. The accretion disk is a swirling mass of material with temperatures reaching millions of degrees. Scientists observe these disks using telescopes and instruments that detect X-rays and radio waves. By processing this data, they create images that reveal the structure and behavior of the accretion disk. These observations help us understand the extreme environments around black holes and the powerful jets they can produce. And then came a global breakthrough. Scientists built a planet-sized telescope network called the Event Horizon Telescope, linking radio dishes across continents to create one massive eye. This network of radio telescopes spread across the globe worked in unison to capture the first-ever image of a black hole. The Event Horizon Telescope team, consisting of over 200 scientists, collaborated tirelessly, analyzing vast amounts of data. Their efforts culminated in a historic moment, unveiling the invisible and providing humanity with an unprecedented glimpse into the heart of a black hole. In 2019 it captured this, the very first image of a black hole's shadow. What you're seeing is light bent by extreme gravity, a glowing ring framing the darkness. This groundbreaking achievement was made possible by the Event Horizon Telescope team, a global network of telescopes working in unison. The data was meticulously processed using complex algorithms, resulting in the final image you see here. This image not only captivated the scientific community, but also the public worldwide. There's another way we see black holes, by listening. In 2015, LIGO detected gravitational waves, ripples in spacetime, caused by two black holes merging. Gravitational waves are distortions in the fabric of spacetime, predicted by Einstein's theory of general relativity. When massive objects like black holes collide, they send out these waves, which can be detected by instruments like LIGO. LIGO, or the Laser Interferometer Gravitational Wave Observatory, uses laser beams to measure tiny changes in distance caused by passing gravitational waves. This groundbreaking discovery opened a new window into the universe, allowing us to observe cosmic events that were previously invisible. These waves confirmed what Einstein only dreamed of, and gave us a new sense, feeling the universe tremble. When two black holes collide, they send ripples through space-time, known as gravitational waves. Detected by observatories like LIGO, these waves provide a new way to observe the cosmos. Scientists can now hear the universe, adding a new dimension to our understanding. This breakthrough not only validates Einstein's theory of general relativity, but also opens up a new frontier in astrophysics. We are now able to explore the universe in ways we never imagined, feeling its very vibrations. So, how do scientists see black holes? They trace their influence, capture their shadows, and hear their cosmic collisions. First, they analyze the data from telescopes and satellites, looking for the gravitational effects black holes have on nearby stars and gas. Next, they use powerful telescopes like the Event Horizon Telescope to capture the shadow of a black hole, which is the silhouette against the glowing material around it. Finally, they detect the ripples in space-time, known as gravitational waves, produced by black hole mergers. These methods combined give us a comprehensive picture of these mysterious cosmic giants. And now, we're just beginning to see what lies in the dark. The mysteries of black holes are slowly unraveling, thanks to the relentless efforts of scientists around the world. With advanced technology and innovative methods, we are peering into the unknown, uncovering secrets that were once thought to be beyond our reach. As we continue to explore, who knows what other cosmic wonders we will discover. The journey has just begun. Thank you for joining us on this journey to uncover the mysteries of black holes. We hope you enjoyed learning about how scientists visualize these enigmatic objects. If you found this video fascinating, don't forget to like, share, and subscribe. Stay tuned for more hidden wonders of the cosmos, where we delve into the secrets of the universe. Follow us on social media for updates and exclusive content. Until next time, keep looking up at the stars.